In order to solve systems of inequalities, we graph them. So the first step is to make sure the equations are ready to be graphed. So that means make sure the equations are in y form, or slope-intercept form. Once they're in slope-intercept form, we're able to identify the slope and y-intercept and graph each line. We're going to graph them on the same grid. Once we've graphed the lines, then we're going to find the solution region that works for each of the lines and shade. So in example 1, both equations are solved for y. They are in y-intercept form. I'll graph the top equation in pink. The y-intercept is -1, and the slope is -3. So I'm going to go up 3 to the left 1, up 3 to the left 1, up 3 to the left 1, down 3 to the right 1, and so on. Because of the equal to line, that means I need a nice solid line through my points. And then I can use a test point. I tend to use 0, 0. It'll work out good in this case because it's not on the line. So when I plug in 0, 0 to that top equation, I get 0 is greater than or equal to -3 times 0 take away 1, which would simplify to 0 greater than or equal to -1. Well, 0 is greater than -1, so that's true. So for this line, I would head towards 0, 0. So I'm just going to mark off with some arrows that for this line, I would shade to the right or above it. Now I'm going to graph the second line. I'm going to graph this one in blue. The y-intercept is 2. Since it just says x, its coefficient is a 1, which means up 1 over 1 in the positive direction. Because it doesn't have an equal to line, I will use a dashed line. Again, I can use that same test point, so if I plug in 0, 0, and I can use that same test point because 0, 0 is not on this line either. I simplify and get 0 is less than 2, which is true. So I will head towards 0, 0 for this line as well, which would be below it. So I now have 4 sections on my graph. Section 1, Section 2, Section 3, Section 4, and the only one that contains both sets of arrows is here in Section 1. So I shade that region. That's my solution to that set of inequalities. Now on number 2, I need to do a little bit of prep work. The top equation's not ready to graph, so I'll start by solving it for y. So I'm going to subtract x to the other side. Then I'm going to divide by -2. But we have to remember, if we're going to divide by a negative, we've got to flip that inequality sign. So I'll get y is greater than or equal to positive 1/2 x, because it was a -1x. -1 divided by -2 is positive 1/2. Minus 3/2. So I'll start down at -1.5. And then my slope is 1/2, so I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Because the equal to line, I'll draw a nice solid line through my points. Okay, so there's the top equation. Again, 0, 0 is fine for my test point because it's not on the line. Always plug your test point into the original inequality so that in case you made a mistake in simplifying, you can start to correct that mistake here. So when we simplify, we get 0 is less than or equal to 3, which is true. So for this line, we'll shade above it towards 0, 0. And on to the second one. So for this one, the y-intercept is -4. And the slope is +3. So I'm going up 3 over 1 to the right. And I would go down 3 over 1 to the left, but I don't have enough space here. Because there's no equal to, I'll use a dashed line to connect the dots. And I use my test point. And when I simplify, I get 0 is greater than -4, which is true. So I shade towards 0, 0 for that line as well. And so I can see I've got both sets of arrows up here in this region, above and to the left of both my lines. So there's my solution set for example 2. In this next example, I have 3 lines. The top equation is already ready to graph. It says x is greater than or equal to 0. Well, x equals 0 on the y-axis. So that's actually just this line here. Let me try again. So the y-axis is x equals 0. I'm using a solid line because the equal to. Because any point along here has an x value of 0. Y can be anything you want. We just needed x to remain 0. Your secondary line says y is greater than or equal to 0. Well, that's the x-axis. If we want y to be 0, you haven't moved up or down at all. So you're here somewhere on the x-axis. All of these points contain a y value of 0. X can be anything. Now the third line needs to be solved for y in order to graph it. And so I'll subtract the 4x to the other side. I'll divide everything by 3, and I'll have -4/3 x plus 4. So I'll start up at 4. And then my slope is -4/3, so I'll go up 4 and to the left 3. I'll go down 4 and to the right 3. Down 4 to the right 3. And then I'll connect the dots. Again, all 3 lines are solid because the equal to's. Now I can't use 0, 0 because it's on my first 2 lines, so I'm going to shift and use the point 1, 1 instead. If I plug 1, 1 into my first equation, I get 1 is greater than or equal to 0. That's true. Plug into the second one, I get the same thing. Plug it into the third one, I have 4 times 1 plus 3 times 1. Is that less than or equal to 12? Well, 4 plus 3, I get 7. Yes, that is less than or equal to 12. So again, my test point, I just slid off of 0, 0 right to 1, 1. And it worked for all 3, so I'm going to shade this region that contains 1, 1. And that is this little right triangle right here. So there's the solution to that set of inequalities. Okay, so let's try some applications of linear inequality systems. Number 4 says 2 manufacturing plants make the same kind of bicycle. The table gives the hour of general labor, machine time, and technical labor required to make one bicycle in each plant. For the 2 plants combined, the manufacturer can afford to use up to 4,000 hours of general labor, up to 1,500 hours of machine time, and up to 2,300 hours of technical labor per week. Plant A earns a profit of $60 per bicycle, and Plant B earns a profit of $50 per bicycle. How many bicycles per week should the manufacturer make in each plant to maximize profit? Okay, so we're going to call the number of bikes produced in Plant A X, and that's what we're showing right here. We're going to call the number of bikes produced in Plant B Y. So it takes 10 hours for each bike produced in Plant A. So 10 times X, plus in Plant B it takes 1 hour of general labor to produce each bike. And they're telling us that altogether our general labor has to be less than or equal to 4,000 hours. Because they said up to 4,000 hours for the general labor. Up to means 4,000 is the biggest. The bigger side needs to open toward that. We can't use any more than that. So we have to be less than or equal to that. So that's our first inequality. 10 hours of general labor for each bike in Plant A, plus 1 hour of general labor for each bike in Plant B. Altogether, those two amounts of general labor time have to stay under the maximum of 4,000 hours. Then for machine time, 1 hour for every bike produced, plus 3 hours for every bike produced in Plant B, and they're telling us up to 1,500 hours of machine time. So we have to be less than or equal to 1,500. So our second inequality, 1x plus 3y, has to be less than or equal to 1,500. Then we've got technical labor. So 5 hours of technical labor for each bike in Plant A, plus 2 hours of technical labor for each bike in Plant B. And they're saying up to 23 hours. So no more than means less than 2,300. So our third inequality, 5x plus 2y, less than or equal to 2,300. As for profit, it says that Plant A earns a profit of $60 for each bicycle. So $60 times X amount of bicycles. Plant B, so that was Plant A, $60. Plant B, $50 per bicycle. So $50 times Y number of bicycles, and that's going to give us our profit. So profit will equal 60 times each bike from Plant A, plus 50 times each bike from Plant B. Now if we wanted to solve the system, we would need to make sure they're ready to graph. So if I take inequality number 1, I need to solve it for y. So I'd subtract the 10x to the other side, and I'd have y is less than or equal to 4,000. Take away 10x. My second inequality, I would subtract the x to the other side. So I'd have 3y is less than or equal to negative 1x plus 1,500. And then I'd divide by 3, so that negative 1/3 x plus 500 is my simplified inequality. And then my third inequality, subtract the x's to the other side. Divide everything by 2. And there are my 3 inequalities in slope-intercept form. Now, in order to graph these, let's take advantage of a great graphing program available on the web and on your iPad. Let's see how to do it in Desmos. Okay, so to graph, I'm using the Desmos app. So if you open up the app, and then you click here, you can enter your inequalities. You don't even have to solve for y. It can handle them in standard form. So 10x plus 1y has to be less than or equal to 4,000. Hit enter to enter your next inequality, which is 1x plus 3y has to be less than or equal to 1,500. 5x plus 2y has to be less than or equal to 2300. And so I've entered them all. You can press the double arrows here to slide that away to see your graph. The problem is I've got a negative 15 to 15 and a negative 10 to 10 window, and my numbers are in the thousands. So I need to go up here to this wrench and change my scaling. I'm interested only in the first quadrant, so I can go from 0 for the x. It should be enough if we go up to like 500. And we'll count by hundreds. And for the y, we can go from 0, but I'd go up higher on the y-axis, so let's go up to 1,000. I'm at step of 100, so I gotta fix that. Okay. So here's my grid, and I can pick it up and move it. And it's shading the solution region for me so that I can see this area in here. So from here, over, up, along there, and across there. That's my solution region. That's the overlap. That's the region that works for all the inequalities. So that's the region we're going to be focused in on. Alright, so since this is our solution region, the vertices of your solution region are always going to give you your maximum and minimum profit, because at those vertices you are using the least or the most amount of supplies you possibly can. And so we never have to test any of the points on the inside, just the extremes, the corners, because there we've maxed out. We've done everything we possibly can, and if we're looking to maximize profit, that's what we need to do. So the next thing that we have to find are the vertices of the solution region. So some are easy to read off. This one right here is the origin, so it's at 0, 0. Here we've got the y-intercept for that second inequality for machine time. Excuse me. And then this is the x-intercept for the first inequality, the general labor inequality. This is at 400, 0. This one sits right here at 300, 400. But this one's not a whole value. So we can't just read it off the graph. We have to actually solve for it. And that's a big part of why we reviewed how to solve systems of equations algebraically. Because now I'm focused in on this line, which is my general labor inequality. I can tell by the slope of it, it's very steeply down, and it's y-intercept, so I know that this is my general labor inequality. I'm looking for where that intersects with this one, which is my technical labor. So I have to find the point of intersection for general labor and technical labor. So general labor, my equation is 10x plus y is less than or equal to 4,000. My technical, 5x plus 2y is less than or equal to 2,300. Well, it's set up for elimination method. I'm going to double the top one. Actually, I'm going to multiply by -2. So I can just add them together. And I'm going to think of them as equations for this. I'm going to keep the second one exactly the same. And now I'm going to add straight down. So -20x plus 5x gives us -15x. -2y plus 2y is 0. Eliminated by design. -8,000 plus 2,300 leaves us with -5,700, -5,700. So if you grab a calculator and take negative 5,700 and divide by negative 15, we know a negative divided by a negative is a positive, and this comes out to be 380. So that's why it's not quite on the grid line, so it wasn't a whole value, because we're counting by hundreds. So then I need to plug that into one of my original equations. Oops. Substitute it for the x value. So if I use that first one, 10 times the x value of 380 plus y is supposed to equal 4,000. So 3,800 plus y equals 4,000. So then y must equal 200. So that this final point of intersection is 380, 200. So now that I have my vertices, 0, 0, 500, 0, 300, 400, 380, 200, 400, 0, I'm ready to test them in my profit equation to figure out which one gives me the maximum profit. Okay, so in the scenario, it told us that we make a profit of $60 per bike from plant A, and we're going to make X amount from plant A, so it'll be 60 times X. Plus, we're going to add on the fact that we make $50 per bicycle made at plant B. We're going to make Y number of bikes from plant B, so we add on 50 times Y, and that's going to give us our total profit. And so now I test each of these vertices. So 0, 0, I anticipate giving me the minimum. If we don't make any, we don't make any profit. If we test 0, 500, so if we purely make bikes at the second plant, we don't make any at the first plant, we're going to come out with a profit of $25,000. If we test the 300, 400, so if we make about the same amount at each plant, we'll make $38,000. If we test out, okay, if we make a little more at plant A, so the 380 and the 200, that's 32,800. And the final one, what if we only make bikes at the first plant and none at the second plant? Something that's at 50 times 10, but 50 times 0 is obviously 0. So you'd only make $24,000 that way. So your maximum profit is $38,000. So to maximize profit, you should make 300 bikes at plant A, and 400 bikes at plant B. So when you have one of these linear programming problems, a situation where there's all sorts of different constraints, and they're asking you to find your maximum profit, step one is to write inequalities to represent your constraints. The chart method can help, but just read through, figure out, what the constraints are, and then what are the two unknowns? How many of what and what are you being asked to produce? Set up your variables so you can write your inequalities, get the inequalities graphed, find the solution region, so find the region that's true for all of your inequalities, shade it, find the vertices, so find these, and again, you'll probably need to do some algebra for at least some of them. If they are not perfectly on the grid lines, you need to solve the system of equations. So take those two equations and find their point of intersection with the algebra. That's why we learned how to solve systems of equations. Then once you have the vertices, write your profit equation, plug each vertex into your profit equation, and figure out what gives you the most. A reminder that the maximum and minimum are always going to be the vertices, because there you've maxed out your supplies.